Hi everyone, today we're going to look at Py6S. Py6S is a Python interface for the 6S radiative transfer model. Before we get started, a little bit about me. My name is Yulan and I study atmospheric correction for aquatic remote sensing. 6S and Py6S are something I frequently use. And when I first started, there was no video tutorial and I had to go through all the documentation to get started. Although you will eventually need to read the documentation to understand how they work in detail. But having a video like this would have helped me a lot in the beginning just to get started. I hope this is helpful. In the video description, I included links to some of the useful documents as well as the code I'm going to use for demonstration. You can check them out for more information. The full name of 6S is Second Simulation of a Satellite Signal in the Solar Spectrum. V stands for vector, and it was created by Dr. Vermode and others. 6S is a radiative transfer tool. It simulates the propagation of light as it moves through the atmosphere. And the tool includes many parameters that are customizable, such as the position of the sun, the reflective properties of the surface, as well as the atmospheric composition. The problem is 6S was written in Fortran and it requires compilation. As technology evolves, it becomes really hard to install all the old libraries. The input and output of 6S, they're not easy to use, which I will show you in the next slide. Py6S, on the other hand, has the Fortran execution file pre-compiled for you, and the interface is in Python, so you can incorporate it in your workflow, your processing chain, more easily. It was a game changer thanks to Dr. Robin Wilson. Here we're looking at 6S input and output. On the left is the raw input file to 6S. You have to make a text file with all the numbers in the right order and feed it into the execution file. It's not easy to do, and it's very easy to make mistakes. And on the right is the output. It's quite long. This is only 1/3 of it. It's basically a text wall printed in your terminal or command line. You could copy the information onto somewhere and extract information manually, but that's not efficient. That's where Py6S becomes super useful. Here's what we're going to cover in this tutorial. We're going to see how to modify the input parameters in a modern programming language, Python. And we're also going to see how to read and extract the output of 6S efficiently. We're not going to cover these topics: multi-wavelength runs, multi-angle runs, and atmospheric correction. Py6S has a documentation for these. You can look them up. You can also reach out to me for help. Here's some sample code in Google Colab. I made a copy of the code and shared it in the video description. You can work along with me as you watch this video, or you can play with it on your own. We're first going to set up a Conda environment by clicking the play button here. This is the code for Google Colab. If you're working locally, you can download Anaconda and you don't need to run the code here. And then we're going to install Py6S using Conda install by clicking the play button again. Alternatively, you can install Py6S using pip, but in my experience, Conda install is easier to use. It may take 1 minute or two to run the two sections of code here, and I'm going to skip it. Here's the main section of the code. I commented out some alternative options for some of the parameters. We're going to look at them one by one, all the parameters, and we're going to run the code and take a look at the output, and we're going to go back and modify the parameters and check the output again. First, we're going to import the Py6S library, and then we're going to create a 6S object which is needed in every 6S run. And then for the geometry, we're going to set the 4 angles, all of them as 0 degrees, the 2 azimuth angles and 2 zenith angles. And for the molecular profile of the atmosphere, we're going to use mid-latitude summer first. And for aerosol profile, we're going to use maritime first. And there are 6 options for each of the 2 here. And then for aerosol optical thickness at 550 nanometers, we're going to set it as 0 first. The next one is wavelength, and we're using 0.4 here. That is 400 nanometers. The number here is in unit of micrometer, so if you put in 0.4, that is 400 nanometers too. And the last one is the second last one is sensor altitude. We're going to use a satellite level first, basically outside, like above the top of atmosphere. And the last one is surface reflectance. We're going to use a homogeneous Lambertian object with a 30% reflectance or 0.3 reflectance. And then the second last line of the code is to run the 6S object with all the settings here, and then we're going to print the full text output. And I'm going to click play, and there we go. You can take a look at the output, see if the parameters here match the parameters in your setting. And as you can see, it's a long list of output, and Py6S has the feature of extracting all of the output information into Python objects. So here, the s.outputs.values, it is also a list, a dictionary, and you can print the keys and the values of the dictionary by clicking the play button here. And there we go. So instead of a crazy text wall, now you have a dictionary with all the keys and their corresponding values. And lastly, you can extract individual values by using their keys in the dictionary. Here we're extracting the value of key background reflectance into a variable called myVariable, and then you can print it to see its value. Here we're going to modify some of the input parameters and then run the code again. We can change the solar zenith angle to say 30 degrees. We use zenith angle to maybe 45 degrees with a relative azimuth angle of maybe 137. And then for the molecular profiles, we're going to make it to tropical instead of mid-latitude summer. And then for aerosol, for the molecules, you can also use a user profile by giving it the water vapor concentration and the ozone concentration. And for aerosols, we're going to make it continental instead of maritime. And then alternatively, you can also customize the aerosol profile by giving it the fractions of the 4 components of aerosols in 6S. They have to add up to 1. And here, the aerosol profile is the type of aerosol. And here, aerosol optical thickness is the amount of aerosol. We're going to make it 0.1, which is a common value. And then the next one is wavelength or band. We can either use wavelength or band. For example, Sentinel-2A, the first band of Sentinel-2A, Dr. Robin Wilson kindly put together all the band information in Py6S, which makes it super convenient. And we're going to modify the sensor altitude from top of atmosphere to maybe 5 kilometers above the surface. And then we can modify this too. There are a few surface reflectance options in 6S. You can check them out if you're interested. And then we're going to run the code again. And you'll see the corresponding change in the output. You can see the geometry here. You can see some polarization information here. And yeah, all the some of the values can be a little off because we're really close to the surface. If we make it to the top of atmosphere again, some of the zeros would disappear. See? Yeah, and we're seeing some transmittances here in the last page. This is the end of the tutorial. Again, it is more for getting you started in using 6S and Py6S. Please refer to the documents for more analysis that you can do. And feel free to reach out if there's anything I can help you with. Thanks.